Hey everybody, today I'm going to be looking at congruent triangles. Before we get going, I'm just going to say I've copied this straight from our textbook. I'll highlight things as we go along so that you can, to indicate that you need to copy those down. But basically I'm just going to talk through what's in the textbook and then you can go and do the exercises. So congruent triangles, two triangles are congruent if they are the same shape and size. All pairs of corresponding sides and angles are equal. So looking at this in this particular case, we've got angle 64 there, we've got angle 64 there, and so on. 45, 45, and the side that's between those is both 3.9, and so on. So if we go around, you'll see that everything is in exactly the same position. So therefore we write that triangle ABC is congruent to, that's the triple equal sign, triangle XYZ. Just a further note, just remember that the naming convention, we go in the same direction. So A, B, C, X, Y, Z. So they're the naming conventions. Same for any sort of shape. I'll get you to copy this down and then we'll have a look at the next slide. This slide talks about the tests to show that triangles are congruent. Now it can be distilled down to four conditions. They are side, side, side. So in other words, all three pairs of corresponding sides are equal. Side, angle, side. That's two pairs of corresponding sides and their included angle. Now the included angle means the angle that's in between the two sides. Angle, angle, side. Two pairs of angles and one pair of corresponding sides are equal. So remember the side has got to be in the same relationship to the two angles. And RHS both have a right angle, their hypotenuse are equal, and one other pair of corresponding sides are equal. Okay, so let's say you could copy all of that down as well. And we'll have a look at the next slide. Now this slide is an example where you have to prove that triangle OTS is congruent to triangle OQP. Now, so the fact that this is drawn in a circle gives us some clues about the radii. So each of these lines here, which go through the center, are radii of the circle, and they're all equal. So, but how we write that is side OS is equal to side OQ. So OS and OQ, corresponding sides. Angle TOS is equal to QOP. Now they are vertically opposite angles. And side OT is equal to OP. So that's the three conditions there. So we have side, angle, side. Just note how concisely it's written over here. You have to give reasons and bracket it next to it. Equal radii, vertically opposite angles, equal radii. And then the final thing is to do a concluding statement. Therefore, by SAS, triangle OTS is congruent to triangle OQP. Okay, very concise, but to the point. Okay, so let's copy this example down into our books as well. Now, next example, I've skipped number 2. Number 3 in the book says, show that triangles ABC and DEC are congruent, hence prove that AB equals ED. Now, so the parallel lines are a bit of a giveaway, and we have transversals happening there. So, the solution, so basically here we have a series of alternate angles. So angle A there is equal to angle D. They're alternate angles. Angle B is equal to angle E. They're alternate angles as well. And angle ECD, that's that angle there, is equal to ACB. And they're vertically opposite angles. So there's a lot of information there, but we've just got to decide which ones we want to use. In this particular solution, they've used angle AAS, so angle BAC is equal to angle CDE, alternate angles, AB parallel DD. Angle ABC is equal to angle CED. Similarly, don't have to rewrite it. And AC is equal to CD, and that was given. Okay, that's the check marks on that. So that gives us AAS. So by AAS, triangle ABC is congruent to triangle DEC, and because they are congruent triangles, AB equals ED, and because they are corresponding sides in congruent triangles. Corresponding sides. Okay, so let's copy that one down as well. And now you can go on and have a go at the exercises. Remember, a lot of these are fairly easy, so I'd pick on the harder ones, cherry pick some of the harder ones, okay?